cover Chapter P, Section 4. Today we're going to begin our process of factoring polynomials. Now, you really need to develop a good skill of factoring because we factor all year long. What I find is probably one of the most difficult parts of Algebra 2 is understanding the directions. So when you're given a question, you need to be listening to the vocabulary and understand what the question is asking. It's all fine and wonderful when you do the homework section by section, but then when you get 15 questions all together and it's all mixed up and it doesn't go in order, like, okay, the first question came from P2, the second question P3, then P4, it's going to be all jumbled up. So it's going to be really important that you're paying attention and understanding what the question is asking you to do. That's a real skill that you need to be paying attention to. What we're going to talk about today, first of all, is finding a greatest common factor. Now, you probably did greatest common factor back in maybe 4th grade when you just found greatest common factor between numbers. Then later on in middle school and in Algebra 1, you probably learned how to find a greatest common factor when variables were involved. Now, whenever you factor any problem, you should always look for a greatest common factor first to factor out. Then what remains after you pull out that GCF, you're going to look to see, can I factor it further? Now today, we're just going to be working on the greatest common factor, the difference of squares, and perfect square trinomials. Then later on, when we continue on with P4, we're going to do some more factoring techniques. But let's first look at this greatest common factor. So we can first look and find the greatest common factor between 6 and 4. And the factor that they both have in common is going to be the number 2, because the factors of 6 are going to be 1 times 6 and 2 times 3. And the factors of 4 would be 1 times 4 and 2 times 2. So the GCF between 6 and 4 is 2. And then we're going to look at the variables. And when we're looking, it's sort of like backwards of the name. We're looking at the exponents. Now, in order for a variable to be part of the GCF, it has to be in common to both terms, or if there's more than one term. So that variable needs to be in all the terms. Notice they both have the letter X, and then I'm going to look at the smallest exponent. So it's sort of backwards of the name. So the GCF here between 6x to the third and 4x is going to be 2x. Now, after you find that GCF, you need to divide it out. Now, what I like to do, just so I can give myself a visual, I like to write the GCF underneath all of the terms in my problem. Because what I'm doing here is dividing each of those by GCF. I'm now going to write the GCF, and then in the parentheses is going to be the answer to the division of 6x to the third divided by 2x. Once I divide that, I'm left with 3x squared. And then I'll divide this one, and I'm left with just a 2. And that would be that binomial with the GCF factored out. Now, if I were to distribute this, it should go back to my original problem. Now, if after you think you've factored, if there's still a factor in the parentheses still in common, then obviously you didn't pull out the greatest common factor, and you should go back and try again. But this is the factored form of factoring out the greatest common factor of the binomial 6x to the third minus 4x. Let's try some examples. Now, it doesn't necessarily always have to be a binomial. It could be a trinomial. It could be a polynomial with 4 terms, 5 terms. You can also have a GCF that's a binomial, and we're going to see that coming up. So let's go ahead and take a look at some examples. So the first one, this is a trinomial. I'm going to look to see what factor they all have in common. Now, notice they all do not have the variable x, so I will not have a variable in my GCF, but I notice all three of these numbers can be divided by 4. Now, whenever we're factoring trinomials, always try to keep your squared term positive. So I'm going to actually pull out a -4 as my GCF. Because this one, we're not going to factor it further, I could have also pulled out a +4, but again, when it's a trinomial, always try to keep that x squared term or whatever variable is squared positive. So -4 divided by -4 is 1, so this is just x squared, and then positive 12x divided by -4 is going to be -3x, and then -16 divided by -4 is +4. You need to write the GCF in front of the answer of all that division. And that would be that polynomial or that trinomial with the GCF of -4 factored out. I'm going to look at the next one. Notice the next one, they all have in common the variable x. So x will be in my GCF. And then I'm going to go back and look at the numbers. And I can see that they all have a factor of 3 in common. So I'm going to divide all of these by 3x. 3x is my GCF. Again, the GCF goes outside, and then in the parentheses, you're going to show the division of each term. 3x to the third divided by 3x is just x squared. -6x squared divided by 3x is -2x, and 9x divided by 3x is 3. The next one, if you look at your terms, this is a term and this is a term, the portion that's in common is the binomial. So my GCF here is actually x minus 2. And again, I'm dividing each of the terms by the GCF. I'm going to write my GCF here. And now in the parentheses goes the answer to the division. So x minus 2 divided by x minus 2 is 1. And then I'm left with 2x. And then over here, same thing. This becomes a 1. And then I'm left with plus 3. And I'm done. So my GCF on this one was a binomial. It was x minus 2. For the next one, same thing. Now, if you think about it, this x plus 3 squared is really this. And again, you can see that each of the terms have in common the binomial of x plus 3. So I'm going to divide this one by the GCF and this one. This cancels. And now GCF on the outside, which was the x plus 3. And now in the parentheses, what remains? Now, notice in that second parentheses, I have some like terms that I can actually combine here. And this should have been a plus 3. This is a plus 3. And then now, the GCF, combine the like terms in the next one, 3 minus 4, and I get -1. Now we're going to talk about the difference of two squares. Now remember, the word difference, this is the word that means the answer to a subtraction problem. So when you have two terms of a binomial, which are perfect squares with a minus sign in between them, that is what is called the difference of two squares. In order to factor them, all you need to do is square root the first and the last terms, and then one parenthesis is going to get a plus sign and one gets a minus sign. Because if you remember, when you FOIL that, the outer and the inner are going to cancel. So for example, over here, the x squared minus 4, both of these terms are perfect squares. So I'm going to square root the x squared. That gives me that term there. And then I'm going to square root the 4. That gives me a 2. And then one gets a plus sign, one gets a minus. Whenever you factor anything, if you have the time to go back and multiply it, and in this case we could FOIL it, if the answer after you FOIL doesn't go back to your original, you've done something wrong. So if I FOIL this, x times x is x squared, that's first. Then outside, negative 2x. Inside, positive 2x. And then finally last, negative 4. Notice outer and inner have canceled, and I'm left with my original problem. So I did choose the correct factors. A lot of time, taking the time to FOIL it will save your answer, especially if you've put in the wrong signs. Now, if the question were x squared plus 4, there is no such thing that can be factored as the sum of two squares. Now, if it had a GCF, we could factor something like that out. But this one cannot be factored. It's prime. Okay, so if this were a question on a test, and if the instructions say factor, then you would just rewrite the question. It can't be factored. Let's try some examples of the difference of two squares. Now, always, you need to look for a GCF first. If you can divide out a GCF first, do that. Now, in this one, there is no greatest common factor between 9 and 49. However, 9 and 49 are perfect squares. It will probably benefit you. When I used to teach this to my Algebra 1 class, I would tell them to memorize the perfect squares up to 20. Okay, you should already know up to 12 from 3rd grade. Okay, and then it's just a matter of memorizing 13 through 20. And a little fun fact with 13 and 14, 13 squared is 169. 14 squared, you just reverse the numbers and it's 196. Now, if you're not sure of the rest of them, you're just going to have to do some quick multiplication here and get the rest of the perfect squares. This is actually 225. So when you start to see these numbers, if they're kind of large and you don't recognize them, quick multiply it. Try to use some benchmarks. Like if the number's greater than 100, you know you got to pick something, 10 or bigger. If you want to memorize that 15 times 15 is 225, and let's say it was like close to 400, know that it's going to be less in between 15, but less than 20. So sort of have a good idea of where it's going to fall. So for this one, again, remember all we need to do is square root this one, and this gives me 3x. I'm going to write it as the first term in the binomial. And then the second term is the square root of 49. One gets a plus sign, one gets a minus. And again, the order that you write the plus and the minus sign doesn't matter. So 3x minus 7 could have been written first, and 3x plus 7. So either answer is acceptable. Now, when you're doing the WebAssign for this, read. They may tell you, put the addition binomial first or put the subtraction. So just make sure that you're reading carefully the format of how to enter your answers when you're doing WebAssign. All right, next one. Still, no GCF here, But I can recognize that 36x squared is a perfect square, and so is 49y squared. So I'm going to square root the 36x squared, square root the 49y squared, and the square root of 36x squared is going to be 6x, and the square root of 49y squared is going to be 7y. And then one's going to get a plus sign, one gets a minus sign. And again, the order that you put the plus and the minus doesn't matter. Now the next one, you may take a look at that and say, wait a minute, 4 and 100 are perfect squares. Watch what happens. I'm going to do it the right way first, and then I'm going to do it the wrong way. So the right way is to look for a GCF first. The greatest common factor between 4 and 100 is 4. So I need to divide both of these by 4 first. And then I get x squared minus 25. It's still the difference of two squares, so I got to keep going. So I could square root the x squared, and I can square root the 25. So I would put 4, and then x minus 5, or x plus 5, either way. And then here again, but this time with a plus sign. So make sure that you look for a GCF first. Now watch what would have happened if you didn't pull the GCF out. So let's take the problem, and let's say you thought, oh, this is a perfect square. This is a perfect square. If you didn't go ahead and factor out the 4 first, notice my binomials still have a GCF that between 2 and 10 that you could have pulled out. So if there's still something in here that you could have divided these two by, then you should have gone back and looked for the GCF. So if you would have done this on the test, or if you do this on the test, you get it wrong, okay? Always, always, always look for a GCF first. Now the next one, 25x squared and 36 are both perfect squares. But notice in between them is an addition sign. This one cannot be factored. So you would either write cannot factor or just rewrite the problem. There are no binomials that you could multiply to get 25x squared plus 36. It cannot be factored. There is no binomials that will give the sum of two squares. Try some more. All right, next one. Now, when you have an exponent that's even on this variable, it's still a perfect square. So x to the 8th is still a perfect square, and so is 1, because 1 times 1 is 1. Now, whenever you have powers that are bigger than 2, chances are you're going to have to keep factoring. It's not going to be a single 2 binomials. So for example, x to the 8th minus 1. I'm still doing the same thing. I'm going to square root this one. I'm going to square root this one. Remember, when you square root a variable with an exponent, you divide that power by 2. So this is going to actually factor into x to the 4th. X to the 4th, that's what the x to the 8th factors into. And then the square root of 1 is 1. And 1 gets a plus sign, 1 gets a minus sign. Yes. Is the sum of two squares. So I can't do anything with that x to the 4th plus 1. But I can keep going on this one. I can divide that power of 4 by 2. So this will actually factor into x squared plus 1, x squared minus 1. And then plus, and then minus. And then this one keeps coming down. Don't forget about it. So we still have the x to the 4th plus 1. And now I still have another one. This is still a perfect square here. X squared is a perfect square, and so is 1. This will factor into x plus 1, x minus 1. And again, keep bringing down all the other ones. So these are still in your answer. So we still have these two. So the final factored answer here for this is going to be x to the 4th plus 1 times x squared plus 1 times x plus 1 times x minus 1. And that will be the final factored answer for this. But it's a perfect square. And again, we're not using calculators yet, not for a long time. So let me write number 10 here. So for number 10, 625x to the 4th minus 1, the difference of two squares. So I'm going to square root this and square root this. The square root of 625 is 25. 25 times 25 is 625. So it's 25x squared. And then the square root of 1 is 1. 1 gets a plus sign, 1 gets a minus. Notice I still have the difference of two squares. So this one I can keep going on. So again, I'm going to square root. This is going to give me 5x. Square root of 1 is 1. 1 gets a plus sign. 1 gets a minus. And then don't forget about bringing this one straight down as well. And now I'm done. So that final answer is 25x squared plus 1 times 5x plus 1 times 5x minus 1. The order that you write all of these doesn't matter. So if you would have written this one first, then maybe you might have had your 5x plus 1 and your 5x minus 1 first, and then the 25x squared plus 1. The order that you write these binomials doesn't matter. Let's try number 3. Not number 3, number 11, sorry. Number 11, 3 minus 12x squared. Now, again, I know I didn't talk about this when I did 9 and 10, but you should always look for a GCF first. 9 didn't have one. There was no variables in common, and the constant, there was a 1. Same thing on 10. However, number 11, there's a GCF here. I can divide both of these by 3. So then I'm ending up with 3 outside the parentheses, 1 minus 4x squared. This is still the difference of two squares in the parentheses. 1 is a perfect square, and so is 4x squared. So again, I'm going to square root. Don't forget about your GCF. It needs to stay in front of both binomials. Square root of 1, and then the square root of 4x is going to be 2x. And then same thing here, 1 and the 2x. And again, 1 gets a plus sign, 1 gets a minus sign. And I'm done. And again, if you would have written the 1 minus 2x first behind the 3, that works as well. But you need to remember to include the GCF out front. Number 12 is also the difference of two perfect squares. Let me rewrite 12 down here. X plus 2 squared minus y squared. These are your two terms, here and here. They're both perfect squares. So what I'm going to do is I'm going to square root and square root. So then this ends up being, let me write it a little bit bigger. So the square root of the first one, whenever you square root a square, it cancels. So I get x plus 2 And then when I square root the y squared, this just becomes a y. One gets a plus sign, one gets a minus. There are no like terms, so that would be my factored answer. Again, always look for a GCF. There is no GCF. So again, same idea here. Difference of two squares. So I'm going to square root. This becomes x minus 1. Square root, let me do it in red. So the square root of the 9y to the 4th becomes 3y squared. And one gets a plus sign, one gets a minus. No like terms to combine, so I'm done. Now the next one, number 14, at first glance you may say, oh, those are both perfect squares, I'm just going to square root them. But if you forget to take out the GCF first, you're going to get it wrong. They both have a GCF of 9. GCF here is 9. So I'm going to divide this by 9. And then what's left, 81 divided by 9 is 9. 36x squared divided by 9 is 4x squared. Notice now I still have the difference of two squares. So I got to keep going. So I'm going to square root the 9 and I'm going to square root the 4x squared. So this will give me the GCF. Don't forget about it. 3 minus 2x. And then you'll do 3 plus 2x. And you're done. One last example of the difference of two squares, and then we're going to go on to perfect square trinomials. Square root the x to the 4th, square root the 16y squared. Parentheses here. Square root of x to the 4th is x squared. Square root of 16y squared is 4y. So x squared here still, and then this is a plus 4y. Now notice the y is not squared, so that's why I don't keep going. Because 4y is not a perfect square. If it were 4y squared, I would have kept going. So in order to keep factoring, that y would have needed to have an exponent of 2. Okay, so next we're going to talk about a perfect square trinomial. Now, one way that you can check to see if the trinomial that's given to you is you'll square root the first and the last terms and then double it. If it gives you the middle term, then all you have to do is square root the first and the last and take the sign from the middle. And let me show you what I mean by this. So to do the test on this one, you would square root the x squared, square root the 25. This is going to give me x times 5. And then I double it. And if that gives me the middle number, then I know this is a perfect square trinomial. And then all I have to do is square root the x, square root the 25. And then they're both the same sign as the middle. So the middle sign was a negative 10x. And this is my answer. This is always going to produce what is called a binomial squared. So you could write your answer either way. So if the given trinomial is a perfect square trinomial, what will result is the same binomial, a binomial squared. Now, when you look at these trinomials, if that middle term is not double the product of the square roots of the ends, then you can't do the trick, okay? You'd actually have to factor it the long way. So it doesn't always give you that middle term. So let's go ahead and try another one. So here again, let's do the trick. We're going to square root this. square root the end. So the square root of 16x squared is 4x. Square root of 9 is 3. I'm going to double it, which gives me 24x. It's the middle. So now I know all I have to do for my answer is square root the 16x squared, square root, and put it there, and then the 9. And again, they're both going to have the sign of the middle. And again, you can write it as 4x plus 3 squared. If when you do this check, if it doesn't give you the middle, then you're going to factor it the long way. We're going to do the same thing. We're going to square root, and then double it. So the square root of 9x squared is 3x. Square root of 25 is 5. And now I'm going to double it, and I end up with 30x, which is the middle. Let's go ahead and put it in here. Since it did give us the middle, all I'm going to do is take the red, the square root of 9x squared, square root of 25, and then it gets the sign of the middle, and it's squared. Or you can write it twice. Same thing on the next one. Square root, square root. Square root of 4x squared is 2x. Square root of 1 is 1. Double it. I get 4x, which is the middle. So now I just have to do 2x plus that square root of 1 with the sign of the middle, and it's squared. Okay, so for the next one, again, we're going to square root. The red gives me 6y. Blue gives me 7. Double it. And I get 84y, which is the middle. So this is a perfect square trinomial. So 6y, sign in the middle is plus, and the square root of 49 was 7. And then the last one, square root gives you 3u. Square root gives you 4v. Double it, gives you 24uv, which is the middle. This is missing a v. Put a v here. And then now we can 3u plus 4v, and it's squared. And you're done. And that is factoring a perfect square trinomial. Remember, when it is a perfect square trinomial, it will always produce a binomial squared.